In the last couple lessons, we ended with some ability to solve some radical equations using graphing techniques. You just put one side of the equation into y1 and the other side of the equation into y2 and then find where they meet. Now we're going to do some algebra to solve them. So what is a radical equation? Very simply, it's just an equation that has a radical sign in it. Okay. How do you solve them? You go back up the order of operations, so please excuse my dear Aunt Sally. You just go start at the bottom and work your way up. And then when you get to the parentheses, you regroup and work your way back up again. Just so you know, roots are in the E category. They're powers. Okay? So we always want to do the opposite when we solve equations. So what is the opposite of the square root is a square. So we're going to square both sides. The square and the square root cancel. X equals 4 squared is 16. And we're done. It says check your solutions. But when you're in this scenario, I'll tell you which ones you can check your solutions. But we don't have to do any checking for these guys. Okay. We're going to assume our math is good. Okay. Anything added or subtracted needs to go first. So I'm going to add 3 to both sides, and that gives me 11 is equal to root n. Now I'm going to square both sides and turn it around. So n equals 121 because n squared is 121. Number 3, anything added or subtracted goes first. So the minus 615 goes first. So 3 root a, and then I have to add 15 over here. And so a positive 15 and a negative 6, I can do that in my head. That's 9. Then anything multiplied or divided to the root goes next. So the opposite of multiplying by 3 is dividing by 3. So we have root a is equal to 3. Now we square both sides. So square, square. 3 squared is 9, so a is 9. These go kind of fast, so we're going to do a lot of them. Okay, anything added or subtracted to the outside of the root goes first. So going in the right order is really important. If you don't go in the order, it doesn't work. So minus 7 to both sides. So root s minus 3 is equal to 4. What I always told myself growing up was try and get the root all by itself. Doesn't matter what's underneath it. Just get the root all by itself. So now that the root's all by itself, you can square it. So we're going to square both sides. So we're left with s minus 3 is equal to 16 because 4 squared is 16. Now we start over again, the order of operations. Anything added or subtracted goes next. So I'm going to add 3 to both sides, and that gives me an s value of 19. Okay. 5, a lot of kids will say, wait, you're supposed to add or subtract first, but this is under the root. So we have to go anything outside first. So we're going to divide both sides by 6. That gives us t minus 2 is equal to 2 when I divide by 6. Then I'm going to square both sides. So square, square. That leaves me with t minus 2. 2 squared is 4. Add 2 to both sides, and we get t equals 6. Okay. A little bit more complicated. We're going to make sure we do this in the right order. We're going to minus 2 first, then divide by 3. Then we get to square it, and then we can solve what's inside. So we're going to minus 2 first. So 3 root 3x minus 6 is equal to 18. Then we're going to divide by 3. So root 3x minus 6 is equal to 6. Now we're going to square both sides. We're going to square both sides. So the left side is 3x minus 6, and the right side is 36. Now that the root is gone, we just solve it like normal. Add 6 to both sides, so 3x is 42. Divide both sides by 3, and that gives me x equals, I think, 14. Awesome. So that's just with one square root. Now, we have 2 square roots. We have to do a little bit of checking our answers here, just to make sure we don't end up with any negatives under our square root. But the math is super easy. Basically, you can square both sides and the square root disappears. So you can just solve for what's underneath. So d equals 5d minus 8. Okay? So we're going to minus 5d to both sides. That gives me the left side is negative 4d, and the right side is negative 8. Then we're going to divide both sides by negative 4, and we get d equals 2. Now, let's say check your answers. I cross that up above, but really we need to be checking for these as we go. So put a 2 right there. As long as I have a positive number, I'm good. So positive, 5 times 2 is 10. 10 minus 8 is 2, so I'm good. So d is 2. 8, just get rid of the square roots. So you can 3c minus 2 is equal to 4c minus 6. I like working with c's on the left, so negative c on the left. Add 2 to both sides is equal to negative 4. Divide both sides by negative 1, and you get c is 4. Now I'm going to put 4 in my head. Positive number, so c is 4. 9, z minus 12 is equal to 1/3 z minus 3. Okay, subtract 1/3 z, so this is 1z minus 1/3 z, so that's 2/3 z, and then add 12 to both sides is 9. So fractions are a little tough for kids, so make sure you understand what I just did there. I just subtracted 1z minus 1/3 of a z, and I got 2/3 of a z. Now, to multiply by fractions, you don't really divide by fractions. You always multiply by the reciprocal. But I always look at it like this. Like when I was a kid, I was like, all right, that's divided by 3, so I'm going to send that 3 over as multiply. So I'm going to times by 3, and that's gone. And then I'm going to divide by 2, and that's gone, so I'm left with z. 9 times 3 is 27. 27 times 2 is 13.5. And then we're going to check and make sure we got positive numbers. When I put a 13.5 there, we're good to go. Okay. 10 is a different style because I just subtracted the roots on both sides. But if I send this minus 6w over, look what happens. Don't get tricky and be like, oh, these are impossible. Just send that over as root 6w, because the opposite of subtracting 6w is adding 6w. When you add it to 0, it's just root 6w. Well, now it's the same problem we just did. So I just had to move it over to make it more simple. So drop the square root. So you just pretend the square root's not even there. I'm going to minus 3w to that side. So 1 equals 3w's. The root is gone. And divide both sides by 3, so w is 1/3. And then when I look and plug it in, I get a positive number under my square root, so I'm good. Okay. 11 is a cube root. There's no restrictions on cube roots. You can have positives or negatives, so you don't need to check your solutions here. But the opposite of a cube root is a cube. So 5 cubed is 125. 12, you can cube root negative, so I'm going to cube both sides. So what is negative 3 cubed? Don't trick yourself into thinking that's something different. That's negative 3 times negative 3 times negative 3. So that's negative 27 is equal to x plus 2. And then minus 2 to both sides and turn it around. So negative 29. Don't need to check your answer. A lot of problems today. That's okay. They're going fast. 13, cube root on both sides. That's not very tricky. We're just going to cube both sides to get rid of the cube root, and then we're left with a simple little linear equation. 7m minus 3 is equal to m plus 9. We're going to minus m to both sides, so 7 minus 1 is 6. M's, add 3 to both sides is 12. Divide both sides by 6. So m equals 2. Okay. All right, 14 is where it starts getting a little tougher, and we need to bring in some prior knowledge and also check our solution. So don't mess with your original. You want to keep your original looking clean, okay? So we're going to square both sides, but we can still see our original equation. So on the left side, I get negative 1 minus 2b, but on the right side, I get b squared. So we spend an entire chapter teaching you how to solve quadratics. You can't use regular algebra when it's b squared. In other words, I can't add 1, divide by negative 2, and then square root my b. It doesn't work that way. The way you solve quadratics is to get everything on the same side. It's called standard form, and set it equal to 0. So this is 0 equals b squared plus 2b plus 1. And then we gave you 5 different techniques: factoring, graphing, looking for x-intercepts, quadratic formula, complete the square, and square roots, which can't use square roots here. Okay? I'm going to factor it. I'm the king of factoring. You get good at factoring, your life will be that much easier. You guys can be the kings and queens of factorings too. So I'm going to backwards FOIL this, and I'm going to get b plus 1 times itself. So b plus 1 squared. And then I'm going to find the 0. What number makes this 0 is negative 1. Okay? So my answer is negative 1, but now I have to go back to my original and see if this makes sense. If I put a negative 1 there, and I put a negative 1 there, they don't equal each other. There's no way I can take the square root of a number and ever get it to be negative 1. So this is a no solution. Basically, the negative 1, we didn't do anything wrong. The negative 1 is crossed out. Not good. Okay? It's X'd off. That can happen. All right, 15. So we're going to square both sides. Here's where it gets a little tricky. Okay? So the left side, 3p plus 19. The right side is p minus 3 squared. So I'm going to write that up above. That's FOIL. Don't FLU it. I let you FLU it in a few lessons in chapter 9, but this is FOIL. So you got to do first, outers, inners, last. So that's p squared minus 6p plus 9. We taught you some shortcuts of how to do that. You first, outers, inners, last, combine your outers and your inners. Okay, p squared means quadratic, so get everything on the same side equal to 0. So 0 equals p squared. If I minus 3p, that gives me a minus 9p. And if I minus 19 to both sides, I get minus 10. Okay? We gave you some tips and pointers to how to solve quadratics. Factoring is by far the fastest and the easiest. So I think it goes p minus 10 and p plus 1. That gives me my correct first, outers, inners, and last. So I FOILed the top. Now I backwards FOIL it, which gives me my zeros are p is 10 and p is negative 1. Okay. All right, now we have to check our solutions. We're just looking for negatives. If I put 10 in, 10 minus 3 is 7, check. But what about negative 1? Negative 1 minus 3 is negative 4. That can't happen. So 10 checks out. I'm going to give that a check mark. The negative 1, sad face, eyes crossed out. No good. Okay. 16. Square both sides. All right, be careful. R minus 1 squared is R squared minus 2R plus 1. It's FOIL. The right side is just R plus 5. Set it equal to 0, so you get R squared minus 3R minus 4 equals 0 when I minus R and minus 5. Factor. You guys be the kings and queens of factoring like me. Your life will be that much easier. I get R minus 4, R plus 1. So much easier than graphing. My solutions are 4 and negative 1. Now I'm going to check. The 4 looks good. 4 minus 1 is 3, but the negative 1 does not look good. Negative 1 minus 1 is negative 2. So the 4 checks out. The negative 1, not so good. Okay. All right, 17. Remember, you can't square both sides unless it's by itself. So we're going to minus 6 first is equal to negative 3. And from the get-go, we're in trouble. You can't square root. You can solve all you want, but you can't square root a number and have it be negative. So this is a bad problem. This problem has no solutions from the beginning. All right, story problems are no different. They just have a little bit of story to them. The period, because this is real life. There's people out there solving root problems every day. So the period p of a pendulum is given by the function p equals 2 pi times the square root of L over 32, where L is the pendulum length. If a pendulum has a period of 16 seconds, what is the length? So we're going to put a 16 right there and then solve. So 16 is equal to 2 pi square root L over 32. I've done a few of these in my day, but I'm going to map this out for you, right? We're going to take 16. We're going to divide it by 2 pi. Then we're going to square both sides. And then we're going to multiply by 32. You always do the opposite, but do it in the right order. So start outside the root, do its opposite. Opposite of multiplying is dividing. Then you have the root, square, and then it's gone. Now multiply by 32. So we'll do this as baby steps. We'll write it out. Okay, so we're going to divide both sides by 2 pi. So 16 divided by 2, put it in parentheses just in case, 2 pi. 2.5465. So 2.5465 is equal to root L over 32. Now we're going to take that number and we're going to square it. That's 6.4856. So 6.4846, is equal to L over 32. Now we're going to take that number and we're going to times it by 32. So times by 32. 207.5 is the length of the pendulum. So L is 207.5 5, and my units are feet. Oh, that's a long pendulum. Pretty cool. Think about that, though. It took 16 seconds to go through one cycle. So think of a pendulum that swings like this. If it swings and then comes back in 16 seconds, that's a pretty big pendulum. Pretty cool, though. All right, radius and volumes. So the radius of a sphere is given by the following formula. The sphere at the World of Sports Museum has a radius of 22 meters. Find the volume. So 22 is equal to the cube root of 3 over 4 pi times v. All right, so I see this, and I'm like, okay, cube root. I got to get to v. So I'm thinking I'm going to cube 22, take that answer. Now the cube root's gone. I'm going to times it by 4 pi, and then divide it by 3. So here we go. We're going to start with 22 cubed, 10,648. So we're going to cube both sides. So 10,648. And now we have 3 over 4 pi times v. So now I need to take that number and times it by 4 pi. That's 133,806.7. So 133,806.7 is equal to 3 times the volume. So now I'm going to divide everything by 3. So just hit divide by 3. 44,602.2. So that's a pretty darn big, and my units are meters cubed because it's volume. That's a pretty big sphere. Okay, that's a comma. Nice job, guys.